Hello students, welcome to the 6th session on shear force and bending moment, that is unit 3, strength of materials, 3rd semester, Department of Mechanical Engineering. So in this session we are going to discuss a few problems on cantilever beam with UDL and point loads. Okay. So, as we have discussed in the previous sessions, that is problems on cantilever beam with the UDL and point loads. So, similarly in this session also we are going to discuss few more problems of different type. Okay. So, that is a 7th problem, a cantilever beam of span 3 meter carries an UDL of 2 kilonewton per meter over a length of 2 meter from support. In addition, it also carries point loads of 3 kilonewton, 2 kilonewton and 1 kilonewton at a distance of 1 meter, 2 meter and 3 meter from the support respectively. Sketch bending moment and shear force diagram. Okay. So, only the statement of the problem is given. So, first you have to sketch the beam diagram, okay, including the loads. So, first you have to read the question carefully and draw the sketch. So, it is a cantilever beam of span 3 meters. First you have to draw a cantilever beam of 3 meter length, okay, fixed at A and free at the other end B. It carries an UDL of 2 kilonewton per meter over a length of 2 meter. So, it is carrying an UDL of 2 kilonewton per meter over a length of 2 meter from support. So, from the support you have to place the UDL for a length of 2 meters and the load is 2 kilonewton per meter. Okay. It is a uniformly distributed load. And also in addition, it also carries point loads of 3 kilonewton, 2 kilonewton and 1 kilonewton. These are the concentrated loads at a distance of 1 meter, 2 meter and 3 meter from the support. So, this 3 kilonewton load is 1 meter from support, 2 kilonewton load which is 2 meter from the support and 1 kilonewton load which is 3 meter from the support. Okay. So, first 3 kilonewton load which is at distance of 1 meter from the support. Second point load is 2 kilonewton load which is 2 meter away from the support, okay, and 1 kilonewton load which is 3 meter from the support. So, 1 kilonewton load which is at a distance of 3 meter from support. So, we have to sketch the bending moment and shear force diagrams. So, first we will see the solution to problem number 7. In that we will discuss shear force diagram. So, to draw the shear force diagram we need to calculate the shear force values. So, shear force values at the salient points, that is first we will discuss shear force at B. So, from right to left we will see the shear force value one by one. So, what is shear force at B? So, when there is a point load on B of 1 kilonewton, so the shear force value will be is equal to the value of the point load, that is 1 kilonewton, and it is a positive shear force. As per the sign conventions, the forces which are on the right side and downward direction is to be considered positive. Hence, the shear force at B is equal to 1 kilonewton. Now, what is shear force up to C? From B to C you can see there is no load, there is no load between B and C. Hence, up to C is also 1 kilonewton. Now, what is shear force at C? So, at C there is a point load. So, we have to add this point load. So, that is 1 plus 2 which is equal to 3 kilonewtons. Okay. Now, we will see shear force up to D. So, from C to D we can see there is an UDL of 2 kilonewton per meter. So, shear force up to D is the previous shear force value is 3 plus this UDL has to be considered. So, when you are calculating shear force, we need to replace it by a equivalent point load. So, which gives the same effect as that of the UDL. Hence, I will replace this by a point load, which is a 2 kilonewton load into 2 kilonewton per meter into the length of the UDL from C to D. What is the distance from C to D? It is 2 meter minus 1 meter, which is equal to 1 meters. Okay, 2 into 1. So, shear force up to D is 3 plus 2 into 1. This is the load, which is equivalent to the UDL. Okay. So, which is equal to 5 kilonewtons. So, what is shear force at D? So, at D there is again a point load. So, that is to be added. So, 5 plus 3 which is equal to 8 kilonewtons, which is at a point D. Now, from D to A, so what is shear force up to A? So, up to A, again we have to consider this UDL, okay, that is replace it with a point load, equivalent point load, which is 2 kilonewton per meter into the distance from D to A. D to A, it is again 1 meter. So, 8 plus 2 into 1, this is the load, which is an equivalent of the UDL. Okay. So, 8 plus 2, which is equal to 10 kilonewtons, and the shear force at A is also same, which is a 10 kilonewtons. Now, by considering these values, we can draw the shear force diagram. Okay. So, now we will see the shear force diagram. So, we have to draw a reference line, 0 line, and now we will see what is shear force at B. Shear force at B is 1 kilonewton. So, it is a vertical line up to 1 unit. So, and mark it as a 1 kilonewton. Then from B to C, it is constant. So, a line which is parallel to the base line. Okay. So, it is constant up to C, and the shear force at C is 3 kilonewton. So, there will be a vertical line because of the point load. When there is a point load, we will see a vertical line from base to this point, we have 3 units. So, it is a 3 kilonewton load. Now, from C to D, okay, from C to D, that is shear force up to D, it is 5 kilonewtons. So, we can mark 5 kilonewton on this line, okay, which corresponds to D. So, from 3 to 5, that is from C to D, there is an uniformly distributed load. Hence, we have to represent this shear force diagram by an inclined straight line. So, there is an inclined straight line from C to D. Now, again shear force at D, due to the point load, effect of the point load, it is suddenly increasing from 5 to 8. So, we have to draw a vertical line. Okay. So, from 5 to 8, it is again 3 units, that is 3 kilonewton. So, which is equal to 8 kilonewtons. So, from again D to A, there is an UDL. Hence, the shear force line is a inclined straight line from D to A. Okay. So, this is up to shear force at A, that is 10 kilonewtons. After this, you have to hatch the portion below this shear force diagram and mark it as a positive shear force, because according to the Sun convention, the shear force is positive. Okay. Now, we will go to the bending moment diagram. So, to draw the bending moment diagram, we need to solve for the bending moment values. So, first we will see the bending moment at B, which is equal to 0, because at the free end always the bending moment is 0 in case of the cantilever beam. Okay. Because there is no distance between this load and this point B, because the load is acting on the point B, the distance is 0. So, bending moment is also 0. Now, moving on to the second point, that is point C, that is bending moment at C, which is equal to this load into this distance. Okay. Do not consider the load which is on the point C in case of the bending moment. We are not considering the concentrated loads which are acting on the point at which we are calculating the bending moment. So, only this load is considered, that is taken into negative sign, it is taken as a negative sign because of the hogging bending moment. According to the sign conventions, hogging bending moment is taken as a negative sign. So, minus 1 into the distance is 1 meters from B to C. So, it is a 1 meter length. Okay. So, we have to consider minus 1 into 1, which is equal to minus 1 kilonewton meters. Now, moving on to the bending moment at D. So, what is bending moment at D? So, for this we need to consider this load and this second point load as well as this UDL. Okay. So, first we will consider the point load 1 kilonewton, which is at a distance of 2 meter from D. Okay. It is, this point load is at a distance of 2 meters from the point D. So, to multiply this load into distance, that is minus 1 into 2. Then again the second point load is 2 kilonewton, which is 1 meter away from this D. So, this is 1 meter away from the point D. So, this distance is 1 meters. Okay. Now, so minus 2 into 1, this is the bending moment for this load. Next, we have to consider the UDL also. So, that is a 2 kilonewton load for a distance of 1 meters. So, now we will replace this UDL by a point load. So, the load is 2 into the distance of the UDL, the length of the UDL is 1 meter from C to D. Okay. So, that is, this will be the load 2 into 1, and distance, as we are considering this point load, equivalent point load is acted at the center, is applied at the center of the UDL. So, the midpoint of the UDL, that is half the length of this UDL, that is 1 divided by 2. Okay. So, the length is half 1 by 2. So, this is load and this is the length. So, we will get, after solving this equation, we can get the bending moment at T is minus 5 kilonewton meters. Now, we will see bending moment at A. So, when we are calculating bending moment at A, okay. So, consider this load 1 kilonewton, 2 kilonewton and 3 kilonewton point loads and a complete UDL 2 kilonewton per meter from C to A. So, it is bending moment at A is minus 1 into distance is 3 meter. So, this load is at a distance of 3 meter from A, and next load minus 2 into 2, distance is 2 meters. So, this is for the first point load, and this for 2 kilonewton load it is minus 2 into 2, and for this point load 3 kilonewton it is minus 3 into the distance 1 meter. Now, we will consider this UDL load. So, we can replace this UDL with a point load at the center of the length of the UDL. So, it is 2 meters. So, from 1 meter from A, the equivalent point load is considered, that is 2 into the length of the UDL is 2 meters. Okay. So, this is the load, and what is the distance? That is 1 meters, that is 2 by 2. Okay. So, length of the UDL is 2 meters, you have to make it a half. So, it is 2 by 2. After solving this, you will get bending moment at A is minus 14 kilonewton meters. Okay. Now, by considering all the values, we can draw a bending moment diagram like this. Okay. So, draw a 0 line, and at bending moment at B is 0, mark 0 here, and then bending moment at C is minus 1 kilonewton meter. So, it is a negative sign. So, it falls below the line. Okay. The point is marked below the line, that is minus 1 kilonewton meters. What is the bending moment at D? It is minus 5 kilonewton meters. Okay. Now, bending moment at E is minus 14 kilonewton meters. Okay. Now, we will join these points. So, first from B to C, it is an inclined straight line, because there is no load between B and C, it is an inclined straight line. Okay. Now, from C to D there is an UDL. So, it is to be joined with a parabolic line, parabolic curve. Okay. So, as per the instructions, when there is an UDL, the bending moment curve will be an parabolic curve. So, from C to D you have to join this with a parabolic curve, and from D to A is again a UDL. So, it is also joined with a parabolic curve. Okay. So, this completes the problem number 7. Moving on to the next problem, that is problem number 8, says the draw the shear force and bending moment diagrams for the cantilever beam as shown in figure. Okay. The sketch of the beam is given in the question itself. So, just you have to copy it and redraw the sketch according to the given dimensions. So, you have to draw it. So, there is a cantilever beam which carrying 2 point loads, one is 2.5 kilonewton and another is 3 kilonewton. 2.5 kilonewton is at the free end and 3 kilonewton is 1 meter from the support, and it is carrying an UDL, that is for a length of 2 meters from D to C, which is a 1 kilonewton per meter load. Okay. So, by considering this, now we have to draw the shear force diagram, and to draw the shear force diagram, now calculate the shear force values. So, from right to the left, we will solve this shear force values. Okay. What is shear force at B? So, shear force at B is the point load, that is 2.5 kilonewton, and it is taken positive according to the sign convention for the shear force. So, it is 2.5 kilonewton. Now, shear force from B to C, up to C it is again 2.5, because there is no load. So, up to C is also 2.5. Now, what is shear force at C? At C there is no point load, okay, but from C it is an UDL between C and D. So, then also there is no sudden increase in the shear force. So, it will remain constant, that is 2.5 kilonewtons. Now, what is shear force up to D? So, now the next point is D. So, up to D, from C to D, it is 2.5 kilonewton plus 1 into 2, because we have to replace this UDL by a point load. Okay. So, which is 1, load is 1 into the distance is 2 meters. So, it is 1 into 2 meters. So, it is 2.5 plus 1 into 2, it is 4.5 kilonewtons. Now, shear force at D is also same, 4.5 kilonewton. And what is shear force up to E? From D to E there is no load, hence it will remain constant, that is 4.5 kilonewton. What is shear force at E? Okay. At E there is a point load, so that has to be considered. So, 4.5 plus 3, which is equal to 7.5 kilonewton at E. Now, what is shear force up to A? It is same as that of E, because no load between E and A, hence 7.5, and shear force at E is also at A is also 7.5 kilonewtons. Okay. Now, we will draw the shear force value by considering these values at the different points. Okay. So, this is the shear force diagram. First you have to draw the baseline, that is 0 line, and at B there is a point load due to this straight vertical line, that is 2.5 kilonewtons, and from B to C it is a constant which is parallel to the baseline. You have to draw a straight line parallel to the reference line, that is shear force at C is also 2.5 kilonewtons. Now, shear force at D, shear force up to D, it is 4.5, mark 4.5 units on this line and join from C to D with the inclined straight line because of the UDL. When there is an UDL, the shear force line will be an inclined straight line. So, increases gradually from 2.5 to 4.5. Now, what is shear force at E? At E is also up to E, it is 4.5. So, you have to draw it as a straight line parallel to the reference line. So, 4.5 will remain constant from D to E. When there is a point load at E, suddenly the shear force increases. So, you have to draw it a vertical straight line up to 7.5. So, shear force at E is 7.5. Now, from E to A it is again constant, that is shear force at A is 7.5. So, draw a straight line parallel to the reference line. After this, you have to hatch this drawing, okay, and place the positive sign conventions. Okay, as per the sign convention, shear force is positive, right. Now, moving on to the next part of the problem, that is bending moment diagram. So, to draw the bending moment diagram, we need to solve for the bending moment, that is bending moment at B is equal to 0. Okay, as we know, at the free end of the cantilever beam the bending moment is 0. Now, moving on to bending moment at C. So, when you are calculating bending moment at C, you have to consider the loads which are on the right of the point, that is C. So, we have a point load 2.5 kilonewton and it is causing the beam to hog. So, we have to take the negative sign for the bending moment. So, it is minus 2.5 and into the distance. So, moment of this force about C is load into distance. Load is 2.5, distance is 0.5. So, load is 2.5, distance is 0.5. Multiply both, you will get minus 1.25 kilonewton meters. Now, the next point is bending moment at D. Okay. Bending moment at D is equal to this load into the distance. Load is 2.5, distance is again 2 plus 0.5, 2.5 meters. So, minus 2.5 into 2.5 minus this UDL is to be considered. So, we cannot directly take UDL. I will replace this UDL by a point load, which is a 1 into load into the distance or the length of the UDL is 2 meters, 1 into 2. Okay. So, minus 1 into 2, this is the load and the distance is half of this length. So, it is considered to be acting at the center. So, that is 2 by 2. Okay. Okay. So, the value of bending moment is equal to minus 8.25 0.25 kilonewton at D. Okay. Now, bending moment at E. So, again we have to take this load, this point load and this UDL. Do not consider the load which is on point E. Okay. So, 2.5 into from E to E, this distance is 3.5 plus 0.2, that is 4 meters. So, minus 2.5 into 4 meter minus 1 into 2, this is the UDL, okay, equivalent point load, it is 1 into 2. So, this load into distance is 1.5 plus 2 by 2, that is 2 by 2 plus 1.5. Okay. So, this is the value of bending moment. So, it will be minus 15 kilonewton meter. After solving this equation, you will get the bending moment at E, which is equal to minus 15 kilonewton meters. Now, the bending moment at A is equal to 2.5 minus 2.5 into the distance from the load to point A is 5 meters. Hence, the moment is minus 2.5 into 5 for this load. Okay. And for this UDL, it is the load is minus 1 into 2, the distance is 1 plus 1.5, it is 2.5 from here to here. Okay. And then from D to the load, equivalent load is 2 by 2. So, it is 2.5 plus 2 by 2. This is the distance between this load and the point A. So, the moment will be minus 1 into 2 into 2.5 plus 2 by 2 load into the distance. Again, there is a point load which is 3 kilonewton downwards, it is taken minus 3 into the distance is 1 meters. Okay. Now, after solving this, you will get bending moment at A as minus 22.5 kilonewton meter. Now, we will draw the bending moment diagram. So, that is first draw the 0 line and mark the bending moment points using these values. So, bending moment at B is 0, at B the bending moment is 0. What is bending moment at C? It is minus 1.25. So, mark minus 1.25, that is below this line because it is a negative sign, and join this from B to C with the inclined straight line. Okay. There is no load, hence it increases gradually, okay, linearly from 0 to minus 1.25. So, it is a straight line. Now, from C to D, the bending moment at D is minus 8.25. So, mark this point and join from C to D with a parabolic curve because there is an UDL. So, it is to be joined with a parabolic curve, and from D to E it is increases gradually linearly. So, it is to be drawn with a straight line, inclined straight line, and at E the bending moment is minus 15 kilonewtons. So, mark 15 units and then join this line with the inclined straight line. Now, what is bending moment at A? It is minus 22.5. Join these 2 points with the inclined straight line. So, minus 15 to minus 22.5, which is increasing linearly. So, it is to be joined with the inclined straight line. So, as the bending moment is considered, a hogging bending moment is taken negative sign, you have to place the negative sign and hatch the drawing. So, this completes the problems on the cantilever beams. Okay. So, after completion of this session, you will be able to draw shear force diagram and bending moment diagram for cantilever beam with the uniformly distributed load and the point loads. We will discuss few questions on this session. It is a multiple choice questions Question number 1, what is the shear force at B? Okay. So, from the given diagram, so you have to calculate the shear force at B. The options are 2 kilonewton, 5 kilonewton, 10 kilonewton and 20 kilonewton. So, you have to solve for the shear force and mark the correct answer. Now, the second question is what is shear force at C? So, the same sketch we have to solve shear force at C. Okay. So, after calculating the shear force at C, you have to mark the correct answer in the given options. The options are 12 kilonewton, 15 kilonewton, 23 kilonewton and 30 kilonewtons. Okay. Now, what is the bending moment at B? So, what will be the bending moment at B for this sketch? So, you have to solve for the bending moment and mark the correct answer. And the fourth question, what is bending moment at C? Again, we have to calculate the bending moment at C. Okay, at point C, you have to calculate bending moment value and you have to mark the right answer from the given options. So, the fifth question, what is the maximum bending moment for the given sketch? So, you have to calculate the bending moment at each point and we have to identify the point where there is a maximum bending moment and you have to find the maximum bending moment value and mark the correct answer. Okay. So, we will see the answers for the questions. Question number 1, option B is the right answer. For question number 2, option C is the correct answer. For question number 3, option D is the right answer. Question number 4 is also option D, and for the question number 5, option B is the correct answer. Okay. Now, we will check the answers by solving the problems. Okay. So, now for the first problem, shear force at B. At B, there is a point load of 5 kilonewtons. So, as per the procedure, it is considered positive 5 kilonewton at B. So, shear force at B is 5 kilonewton. So, the correct answer is option B. Okay. What is shear force at C? So, shear force at C is equal to this 5 kilonewton load plus this UDL load. Okay, we have to consider the UDL of 2 kilonewton into the length of the UDL from C to B, which is 5 minus 1, 4 meters. This is 4 meters. Okay. So, 2 into 4 plus the point load which is on C is 10. So, 5 plus 8 plus 10, 18 plus 5, which is equal to 23. So, the correct answer is option C, 23 kilonewtons. Okay. So, moving on to next question, what is the bending moment at B? So, it is a free end of the cantilever beam. If there is a point load or if there is no point load, if there is an UDL or there is no UDL, it does not matter. At B, the bending moment is always 0. So, the correct answer is option D, 0 kilonewton meters. Next, fourth question, what is bending moment at C? So, to calculate the bending moment at C. So, bending moment at C is equal to this is a load 5 kilonewton load into distance from C to this load is 4 meters, 5 into 4 plus, or you are considering a negative sign. So, this is minus 5 into 4 minus the load UDL just to be replaced by point load 2 into 4. So, it is minus 2 into 4, okay, and the distance from here to here it is 4 by 2, 4 divided by 2, okay. So, into distance load, in this is load, this load is acting at a distance of 4 by 2 from C, and no need to consider this load because it is acting on point C. So, when you are calculating bending moment at C, there is no need of considering the load on that point, okay. So, after calculation you will get minus 5 into 4, it is minus 20, and it is minus 16. So, which is equal to minus 36. So, in the options it is given 36 plus 36. So, they have neglected the sign convention. So, but the value is 36 kilonewton meters. So, only we are considering the value. So, hence the answer is 36 kilonewton meter. Okay. The next question, what is the maximum bending moment for the given sketch? So, usually for a cantilever beam, maximum bending moment occurs at the fixed end of the support. Okay. So, hence we have to calculate bending moment at A. So, this is at this point there will be a maximum bending moment. Hence, the bending moment at A is equal to this load 5 minus 5 into 5 minus the UDL, total length of the UDL is 5 meters, that is 2 into, from B to A it is 5 meter, okay, 2 into 5, and this is acting at the half of the distance of 5 meter, that is 5 by 2. Okay. Minus 2 into 5 into 5 divided by 2. Minus 10 into 1. Okay. So, 5 is 25 minus 25 minus 2 get cancel 25 minus 10. Okay. So, which is minus 60. So, the correct answer is option B, which is 60 kilonewton per meter. Ignoring the sign conventions, the only we are considering the value which is 60 kilonewton meters. Okay. All right. So, this completes the session. Thank you.